All right, HG, here we go with 12-3. And I'll get my iPad joining here so that we can have that at our disposal. And what else do you need to have for this? Well, a couple things. One, you're going to need to have your blank notes that look like this to start. And we're going to do that, and then we'll do the next side. And then it's going to say on the next page to go to attached handout. See that at the top of that page? That's this handout that has problems 11 and then 15. Okay, and then once we finish that, we're going to go back to this page here. Okay. All right, so let's go ahead and get started with this. Let me share my screen, which is the 12.3 notes. And all right, so proper mind frame problem, okay? I want you to think of a 24-inch segment that's divided into two segments in a ratio of 5:3. Find each segment length. I'll give you a hint if you haven't figured out how you want to do it. I'll give you a couple seconds. How many, if it's 5 and 3, there's really 8 kind of parts to this, aren't there? And it's 24 long. So you probably figured this out, but basically if you made this 5 parts and this 3 parts, or 5x and 3x, and the whole thing is 24, then each x is 3, which means that the 5 of the 3 is 15, and the 3 of the 3 is 9. Okay, now you'll see why that's important as we go along here. Okay, so here we go. Here's the basic proportionality theorem, which I also like to call side splitter, and you'll see why it's called side splitter in a second. All right, if a line is parallel to one side of a triangle and intersects the other two sides in distinct points, then it cuts off segments proportional to those two sides, okay? Notice this hopefully reminds you of something else that we've done. Probably reminds you of the midline theorem, but here we're not talking about connecting two midpoints. We're just saying any points as long as it's parallel. Okay, so here we're saying DE is parallel to BC and obviously intersects AB and AC just in distinct points D and E. Okay, if that's the case, then that means that AD over AB would equal AE over AC. Okay, it also means that AD over BD would equal AE over CE. Okay, you probably can see why we call it side splitter. All right. You also have the converse, which basically says if the line intersects two sides of a triangle and cuts off segments proportional to those sides, then the line is parallel to the third side. Okay. All right. And you can probably see, well, let me ask you, why do we know this works? Can you see the similar triangles, right? If these are parallel, isn't angle ADE and angle ABC, aren't they congruent? And angle A is congruent, right? And also isn't angle AED and angle ACB, aren't those congruent? Again, if we know these are parallel, then those are congruent by PCA, aren't they? Okay. Lovely. Let's practice this. Okay. If SB is 3, I'm sorry, find SB. Sorry, if C, I was like, what? If CR is 3, okay, CR is 3, I've got that labeled there. RA is 5, go by the numbers, not by what it looks like. And CS is 4, find SB. Notice you've got parallel there. Okay, so go ahead and pause the video and try it. And now I'm back. Okay, so one way to set this up would be 3 over 8 equals 4 over 4 plus x. Then you could cross multiply. So 4 times 8 is 32. 3 times 4 plus x is 12 plus 3x. And then what could you do? You would subtract 12, which is 20, divide by 3, and you get x equals 20/3. Or maybe you set it up 3/5 equals 4/x, in which case 3x equals 20 when you cross multiply, and you get x equals 20/3. Okay? And we can do that all because we know that that's parallel and intersects those two sides. Okay, same diagram. What if CR equals SB, RA is 4, and CE is 4? Maybe use a different color and maybe write the numbers in. Maybe that would help you. Okay, go ahead and pause the video, try it. Okay, I'm back. Okay, so the way I set it up was I made X be what the length of CR is and SB is. So X over 4, so CRX over 4 equals 4, which is, right, SB, right, over X. And so you get 4. Okay, again, you could cross multiply x squared equals 16, and obviously square root of 16 is 4, -4, but we're not going to take the negative. It's a distance problem. All right, next problem. What value for x makes RS parallel to AB if CR equals x minus 1, RA is 5, CS is 1, and SB equals x plus 3? So go ahead and give that one a shot. Same diagram. Okay, back. Here's how I set it up. X minus 1 equals 5. X minus 1 over 5 equals 1 over x plus 3. Okay. Again, I would cross multiply. Your favorites. Subtract 5 from both sides, so I get it set equal to 0. Try factoring. It worked, thank goodness. X plus 4x minus 2, which means x equals -4 and 2. But if we use -4, then we're going to get some negative distances, which we can't. So we use 2. Okay. All right. So now I want you to go to the attached handout, which is, again, that is, first side would be this theorem right here. You see that? Okay. And this, again, should be in your notes packet. All right, so let me change the share and go find that. And it's funny how that does that. Okay, here it is. Lovely. So let's scroll down. And okay, so the reason I'm doing this as part of the lesson is these are, again, 2 more theorems that they're introducing in the notes packet. And I think that it's good for us to go through these. All right, so the angle bisector proportionality theorem. The angle bisector proportionality theorem. We're going to set up a proportion, aren't we? Yeah. Okay, it says the bisector of an angle of a triangle separates the opposite side into segments whose lengths are proportional to the lengths of the adjacent sides. Okay, the bisector of an angle, so here you can see angle A is being bisected, okay, separates the opposite side into segments whose lengths are proportional to the lengths of the adjacent sides. So in other words, in this particular case, BD over CD equals BA over, so BD over CD, those would be what? The parts of the adjacent side of the, I'm sorry, of the opposite side, right? So we're talking about angle A that's bisected. That's going to equal BA over CA. Okay. And how are we going to prove that? Okay, they give you a hint. Introduce CE parallel to AD. And what allows us to do that? We can always, right? We can always introduce a parallel that's through an external point, right? And parallel to a line. So go out to that point now. Okay. If we know that CD and DA are parallel, what does that tell us? Doesn't that tell us that by PCA, that what we have listed here as angle AEC, or the X, is equal to angle BAD in terms of this M. So X is equal to M. And also by PAI, wouldn't that mean that angle or Y is going to equal to this M? Well, if Y is equal to M and this M is equal to this M and this M is equal to X, doesn't that mean that X and Y are congruent or equal? Which means what kind of triangle is triangle AEC? It tells us that it's isosceles, right? Because these two angles are congruent, therefore their sides opposite are congruent, okay? All right, well, what in the world does that tell us? Well, we already know from the theorem we just talked about, right? That we know if AD is parallel to EC, then we could say that AD over DC equals BA over AE, right? Right, by angle proportionality theorem, right? Or I should say, that wasn't what it was called. Let me make sure I get it. The basic proportionality theorem by side splitter, right? Let me go through that again. If we know that DA is parallel to CE, right? We know that it cuts off proportions where AD over DC, right? Why am I saying AD? That's a B. My bad, sorry. BD over CD, BD over CD, see that right there? BD over CD, Mr. Kalen, equals BA over AE, right? But that's not what we're trying to prove. We're trying to prove BA over CA. But don't we know that EA and CA are congruent? Therefore, we proved it, okay? If you want to take a second, you can always pause the video. I've got the explanation right up here, but that's what we did. Not this part, just this part. Okay, flip the page over and let's take a look at the number 15, which is the parallels proportional segment theorem, okay? And that's using this diagram right here. Okay, if 3 or more parallels are each cut by 2 transversals, okay, 3 or more parallels, you can see L1, L2, L3, right, are cut by 2 transversals. Here we have T1, here we have T2. The intercepted segments, remember intercepted segments like would be AB would be an intercepted segment between L1 and L2, so would DE. Then the intercepted segments on the 2 transversals are proportional, okay? In other words, AB over BC is going to equal DE over EF, okay? And notice their hint. They said introduce either DC, or what they did in this case, they introduced AF, okay? All right, well, what do we know? We know that L2 is parallel to L3, isn't it? We also know L2 is parallel to L1, don't we? Okay, so if L2 is parallel to L3, doesn't that mean that AB over BC is equal to AG over GF? Side splitter, right? Okay. Don't we also know that because BE or line 2 is parallel to line 1, don't we also know that AG over GF is equal to DE over EF? So in other words, we know the ratio of AB over BC and DE over EF are both equal to the same ratio of AG over GF. Well, doesn't that make them equal to each other? Yes, it certainly does. Okay, if you want to see the solution to that, you can read this here. Okay. Remember basic proportionality theorem, I call it side splitter. All right, now we're going to go back to those notes. Let me change the share again and go back to 12.3, and we're going to practice this a bit. Okay, let me close that one. And here we are. No, we have to do this. Okay, so here we go. All right, this is going to practice the angle bisector proportionality theorem. Okay. So, all right, look what we have here. We have these two angles equal, okay, which means that CD is a what? Yeah, it's an angle bisector. Okay. If AC is 3, so I'm using the numbers in blue here. If AC is 3 and BC is 5 and AB is 7, again, we're using the blue numbers, find AD and DB. And I've kind of given you a hint in terms of how you might want to kind of set these up. If one part of segment AB is called X, let's say AD, then wouldn't the other part be 7 minus X? Similarly, if you wanted to, you could have called this X and this would have been 7 minus X. Doesn't really matter. Okay. All right. But now, based on what you know from that theorem, the angle bisector proportionality theorem, how could we set this up? Well, we know that we could say 3 over X is equal to 5 over 7 minus X. Another way to think of this is we could say 3 over 5 is equal to X over 7 minus X. It doesn't really make a difference. And you can see both of those there. Either way, when you solve these, you're going to end up getting X is equal to 21 over 8. And if X is equal to 21 over 8, well, that's what AD is. And then DB, remember, you have to subtract whatever AD is from the total length of the segment, which was 7. So 7 over 1 is the same as 56 over 8, and 56 over 8 minus 21 over 8 is 35 over 8. Okay. All right. Now use the red numbers and figure it out with that situation. All right, I'm back. So let me uncover here. So one way that you could have set it up would have been 4 over X equals 8 over 10 minus X. And then you would have cross multiplied 40 minus 4X equals 8X. And then obviously you would eventually end up getting 10 over 3 for X, right? Because we would move that over and make it 12X, divide both sides by 12, and 40 over 12 reduces to 10 over 3. Okay, so that's what X is. Then we need to find AD and DB. And if we know X is what AD is, then it's 10/3. And DB would be 10 minus 10/3, or 30 over 3 minus 10 over 3, which is 20 over 3. All right, great. Let's try this next one. What if AC is 3, BC is X, AD is X minus 4, and BD is 4? Find X. Again, same diagram. Okay. All right, I'm back. So one way to set this up would have been X minus 4 over 4 equals 3 over X. Cross multiply, move the 12 over. It factors to X plus 2, X minus 6. And then you end up getting X equals negative 2 and 6, but X is a negative, does not work here because it would get us some side lengths that are negative. Okay. All right. Awesome. Onward. Okay. So now we're going to practice the one that we just did with the 3 parallels. Okay, that theorem. And notice that we have lines MN and OR parallel, and then we have our 2 transversals here, right? Okay, so you need to find what EF is if we know 12, 18, and 15. Okay. All right, so try it. And I'm back now. So one way to set it up would be 12 over 18 equals 15 over X, or over EF, because we don't know what it is. Another way would be to say 12 over 15 equals 15 over X. I'm sorry, 18 over X, my bad. Yeah, 12 over 15 equals 18 over X. And either way, you set it up, we end up getting 22.5 for X. And since we designated X to be what EF was, we are done with that problem. All right. So hopefully that helps to explain and kind of go through those 3 theorems really that we did. Side splitter, I guess it's converse, and then the angle bisector proportionality theorem, and which we had, oh, we practiced right here, not there, right there. We practiced using that, right? And then the parallels proportionality theorem. All right, wonderful. And that does it for 12.3.